Welcome to Study Loop.
Welcome to the problem number 22.58. This is chapter 22, Gauss law. This is a very interesting problem. So in this question we are given that there is a long cylinder and has contained some charge density rho. So rho is the charge density. And within this there is a hole passing through the whole cylinder which has radius A and is at distance B from the center of the cylinder. So this is a another hole which is in cylindrical shape passing through this hole. So if you want to expand this one, so this is our hole. And this is an insulating material. So this is a hole. So in this condition, we are given that the hole is not coaxial. That means which has been given that this hole is at distance B and has radius A. A is smaller than B and which is smaller than capital R. So in this condition we have this much hole and outside this region we have rho charge density. So we need to find out the electric field inside that hole. There are many ways to do this question. So the one I am using, it's very intuitive and very easy. So let's take a small cylindrical shape Gaussian surface. So this is our hole, these are same, and this is a cylindrical shape. Don't think that this cylinder has something to do with the cylinder. So let me try to project this one here. So this cylinder is exactly seems like a small cylinder here passing through this one. So looking at this one, you have this cylinder and this is a surface which has containing rho volume or rho charge density, and whatever the volume we don't need to care about that this way. So let's apply the Gaussian law or the Gauss law for this surface. So we have E dot ds equals to q enclosed over epsilon. Let's take that the hole has distance, or the point in the inside that hole is x at distance x from the surface of this hole, and we are digging also the same distance x inside that which has containing charge rho. So if you want to project this one, so let me make it more clear. So this is our hole and this is our sphere. This is our sphere and this is our cylinder, and this one is the face of the cylinder, and this one contains rho charge density which is this one and which is this one. So this is the hole. So my q would be equals to rho times x times area of this one. So let me point out what is the area. So this is the area because it's in cylindrical shape. So if you multiply by this one, so this would be the volume. So over epsilon. Now E dot ds. Looking at the E dot ds, we have both two surfaces. So we have E here and we have E here. So 2EA. So this gives us E goes away. And so E gives us equals to rho x over 2 epsilon. But now, first we have to find out that what is x here. So x, the maximum value could be that till the center, from the center of this one. So x would be equals to b. So electric field would be rho b to E naught. The reason is because if we take some other part, if we take some other part of the contribution, let's take this volume, this would not contribute because we might have some other part which would be cancelling the same electric field. But this charge having radius this one would contribute the whole electric field within the hole. So that's your answer for this question. Thank you for watching the video.